target wake time. So Jacob, I know that you've been looking into this, and if you want to, pick up some of the discussion here around what target wake time actually is and what it's actually going to, deliver.
Sure, thanks, Jeff. Yeah, this is just like Nate just said. This is just a small part of the whole Wi-Fi 6. In its basic form, target wake time is basically a new feature that allows an access point and stations to wake up at negotiated times. The stations and the access points agree on a time that defines when the station is awake to send and receive data. So this picture here kind of shows a nice simple version of that. The AP is beaconing out, triggering its TWT and these users that have these devices. Instead of broadcasting and having traffic or being awake, even from like a battery standpoint, they just wake up at negotiated times and increase the efficiency of the batteries of these devices. And I think there might be a really large impact on some of these devices consuming little to no energy at all, when now they would be negotiating and sending traffic all day.
Yeah, I heard a discussion at some point that some devices sleep for milliseconds at this point. And just think about the difference between like an IoT device that has to check in every even if it's a second, every second it wakes up and checks in. I don't know if that's the case, but
it's gonna
have a device like that might only be there for temperature readings or something like that, and it doesn't need to be on all the time. Being able to have that device come online and say, hey, I'm going to check in once an hour or once every 24 hours. Just think about the battery efficiency that you can get out of that not being connected to the network all the time. It's crazy.
I mean, we see that now with our cell phones being on a wireless network or even using our LTE. If you have an older device, even some of the newer ones with new code, you can see that it keeps trying to receive that signal, and it does drain the battery. If you have an older device, you can see your battery actually just going down right in front of you.
Without a doubt, man.
Some other things. This low power standard was specifically designed to support large-scale deployments of IoT. This was further evolved in 802.1x. This has been around since 802.11ah. Really, this is just to optimize power saving for more reliable and deterministic LTE-like performance.
It is kind of interesting to think about some of the last piece in there too, like how this actually helps overlapping service sets. So basically the BSS coloring, how just by having a device that only checks in once a day rather than once a second, just think about how much less congestion you have out there, connecting to things as well. Like there's a lot of noise that potentially goes away for devices that are basically passive.
Yeah, and this is just another bolt-on, along with all these other features that Wi-Fi 6 has. But yeah, it's out there collecting information about predefined periods, about channel sounding, buffers, and it's able to use that information more efficiently. So this is going to save power. It's going to enable devices, to have a lot less traffic out there. Even if it's just a little bit, it adds up over all the devices on that Wi-Fi network over the whole period of time. This is definitely going to make an impact, and it's just another bolt on to what we've already been discussing. So I can see this improving in the future. So
yeah, it's kind of interesting. Like that's something that has always been sort of taken for granted, that the AP, it tells the clients when they need to check in. This really flips that the other way around. So it's a handshake between the two.
Yeah, I don't understand yet how you set that up, or if that's automatic, or like how that negotiation is going to happen. But I don't know. Does anybody here happen to know how
Yeah,
stations?
I think it's probably gonna I think it's gonna probably evolve. And I would say this is more of a just you know a grouping of parameters to kind of say, okay, we're going to kind of push through with this whole idea of, like Jeff said, a handshake, because if you look at how power is developed on mobile devices over the years, it's really one of the more faster moving technology benefits. You know, it's a selling point, right, to a wireless device. Like for instance, whenever the idea of the Q iPads came out, right? Where it was like, hey, you could have a remote wire or remote charging, or if I had a pad, I can charge versus an actual physical cable I had to plug in, whatnot. That was a selling point, right? Anything that's a selling point, I don't think they've squeezed that everything out of that technology yet. What that tells me is it tells me that it's probably going to keep developing, like you said, Jake. So I think this might even look very different in a year and a half. On how they accomplish this. I think the idea of there's a client communication, or there's a two-way communication versus access point being the bully. I think that fundamental understanding will remain, but how it's accomplished, I think, is going to change over the time.
Yeah, I agree.
And I haven't seen anything else out there as far as how this can be tuned or configured from either end, either the client or just from the AP or in the environment. So right now, it's still kind of a mystery.
Yeah, I wonder if it'll be a dynamic, like a dynamic thing. Yeah, I'm not sure.
I mean, I think it could be. I mean, in a lot of cases, I think Nate's point is well taken. Like this, the fact that this is baked into the standard day one, it's great, right? If we can have that handshake and have that capability, but I think a lot of it's going to be delivered, really determined by the clients, right? So the next generation of phones, next generation of IoT devices, certainly, scalability. IoT is not usually the bleeding edge on the network side, but I could see there's a lot of additional benefits, especially when it comes to things like battery life. If you're talking about IoT devices that are, periodically checking in on Wi-Fi, but are sitting there with batteries, whether they're tags or thermometer agents or um, light sensors or sound sensors, anything like that, that would actually be sitting on like a lithium battery somewhere that just checks in periodically. Having that device not have to check in on a second by second basis should over time dramatically increase the viability of those batteries before they have to be replaced. So um, it'll be
Yeah,
interesting to see how quickly. I'd imagine that the phones will be among the first to really take advantage of this, but I think some of the biggest benefits might actually be on the IoT side with things that aren't on rechargeable batteries.
yeah. It's not always feasible to run, an electrical line, or there may not be an outlet, close to plug in. So yeah, I can see this having a big impact in that space.
Yeah, and if you're dealing with RF tags on a mobile cart, you probably didn't want a cable attached to it. So
Yeah, without a doubt.
yeah. So that brings us to our next topic. Ed, we've been talking about this for a while. I know that there's a lot of things about Wi-Fi 6 that we're pretty excited about, but with everything else that we've talked about, if you want to, you maybe talk a little bit about multi-user, multiple in, multiple out, and what that's going to bring to the table. We can tie up the last of the technical topics here.
Sure. Well, I mean, it stays within the same thread of high efficiency. You're just, you're going to be providing for more ways to transmit data. So doubling the number of streams and adding a whole gigahertz band, with the addition of 2.4 in 6. So one of the interesting things too that I saw was the fact that, and I just read this morning, but the full-fledged uplink and downlink communication to and from the clients in the AP is only going to happen in wave 2. So.
Oh, it is interesting. Like as we've gone through and dug into a lot of this detail, what I didn't really appreciate was when we talked about 11 AC, there was wave 1 and wave 2 APs. There isn't a wave 1 and wave 2 standard. They just implemented the core functions in wave 1, and they added a lot of add-on benefits in wave 2. So it's going to be interesting to see how the manufacturers actually deploy that, I think, when it comes to Wi-Fi 6. To your point, some of these, if you actually go back and look at that previous slide, AC wave 1 was single user MIMO, right? And wave 2 was multi-user MIMO. But that was just on the downlink. So what you're saying is that Wi-Fi 6, if there's a wave 1, the uplinks are only going to be single user MIMO. Is that right?
So reportedly, and this is just, from what I've read, and this is all still in the draft, but when we're going to 6, the first iteration is going to give us MU-MIMO for downlink communication. So that's everything from the AP to the client. So we'll have to wait, as far as, just from what I've read, we're going to have to wait through the second iteration first to actually get the full uplink and downlink communication on both 2.4 and 5G. Yeah. I mean, it's really just, think of just more means of communication. You're running from adding the number of spatial streams from 4 to 8, which gives you, let's say each one of your clients then has one antenna, then you can have 8 streams running back and forth between the client and the AP at a time. Or, it's something that we've yet to see on the client side devices, but adding potential antennas to these devices as well. Right now, I think in a lot of cases, most devices just have one. So they'll be able to go, the client itself and the AP are going to be able to communicate back and forth simultaneously.
What I thought was kind of interesting is thinking about this. If you're doing, if you have 8 separate one spatial stream clients, right? Are you going to be able to have a 2U or a 2RU communication actually going out from that AP to 8 concurrent clients? Like when you start thinking about things in that way, like this really, like the scalability of the communication here really dramatically changes, right? I mean, we were pretty excited about that additional bandwidth, but is that how that's going to work?
That's my interpretation. And, going back to what Nate said, when you think about these things, as a whole, and when you layer them together, it's rightfully earned its name as, high efficiency wireless, HE. So, I think one of the other minor things too, and I'm not sure, how much water this holds, but another thing is reported there's going to be improved beamforming just because of the number of spatial streams that are going to be available. So said targeting from the AP to the client.